Hello class, in today's session of your computer-aided engineering 1, we'll be looking at the basics of C programming, and the synopsis for the course is on your notes on page 3, as you can see here. So we'll look at the brief history of your C programming, and we'll look at some basic concepts of C programming in this session. Now, your C program is just one of the numerous high-level languages that you have by which you can write your programs on your computer systems. Just like you have your Java, you have your Python, you have your MATLAB, you have your Scilab, you have your Octave and such programs like that. Your C program is equally one of such high-level programs that you can use to write programs on your computer systems. But in this class, we're looking at your C program. Now, for you to write any program, there are two things involved. Now, programming is just about how you want your computer to actually solve a particular problem. Now, for your computer to solve a particular problem, the user or the programmer in this case must also know how that problem can be solved, because your computer will require the program. But for you to develop a program, you must have the algorithm. Your algorithm is just a step-by-step method by which you want the computer to solve a particular problem. So from the algorithm, you can now develop your program. Now, for instance, let me say you want to add two numbers together. The first thing you would want to do, you want to specify the two numbers, and you would want to use the sum arithmetic operator to add the two numbers together. So that forms the algorithm, how the problem is to be solved. Number one, you need to specify the two numbers to be added. Then you need the operator, which is the addition operator in this case, to add the two numbers together. So from there, you develop your program by which your computer can now solve that problem. Now, there's so many operating systems. These are the basics by which your system works. Without the OS, there's no way any system can work. Your system cannot interface from your hardware to software without the appropriate operating systems. And one of such is your Unix, which forms the basics for your Linux and your Mac OS. Your Windows is another popular OS that you might be familiar with. So operating systems are very important. Without them, there's no way your computer operations can be possible. Now, for every program, there's what we call the compiler. Now, the compiler, what it does is to convert or to translate the program that a user has written in a high-level language, because your programs are written in human readable languages, but your computer do not understand the human readable language. It needs to be translated into what we call the machine language. So what the compiler does is to analyze the program and translate the program into the suitable format, which is the machine language now, for the computer system to understand and execute. So you write in human readable language, but the compiler does the translation into the machine language for the CPU to understand and execute such programs. So without a compiler, there's no way any program, be it Java, be it Python, be it C or C++ or whatever it is, there's no way such could be executed on your CPU without a compiler. Now, for your C program, the very much common compiler that you would see is your GNU/C++ compiler. That is the most common compilers that you would see for your C program. Now, the other thing you would be familiar with as we go along is what we call the IDE, that is the integrated development environment. Now, with an IDE, you can edit, compile, run, or debug your program using a single application. If you are familiar with your Arduino IDE, if you write an Arduino code on your Arduino IDE, you can do the editing, you can compile, you can run the program, you can debug, and at the same time you can link to the hardware, which in that case would be your Arduino. But in this case, we are dealing with just your C program, and your IDE are just applications which are Windows-based program that allows you to manage large software programs by way of editing your files. You can compile the program, you can run, and you can debug your errors, and at the same time you can link with your external hardware. Now, the first thing you want to do is to download your C program, and you can do that just by going to your SourceForge, because your C program is an open source program, so that you do not need to make any payment or subscribe before you can download and use such open source software. So you just need to go to Google and just put in maybe code blocks for Windows or for Linux, depending on your OS in this case, and you just download to your system. So once you download, you go to your download folder, wherever that is on your system. Then you can find your code blocks there. Then you can just run the setup in this case, and you would have your code blocks on your system. I won't be running this again because I already have code blocks on my system. I just want to show you what it looks like. So once you download, you have it in your download folder. You just need to run the setup and it will be installed to your system. And once that is done, you have the shortcut of code blocks on your desktop in this way. So all you need to do is just to double click, then it would open the code blocks. Now, this is the interface you first of all encounter. It will ask, probably you want to create a new project or you want to open an existing project. So I would just show you how you create a new project. Just click that, create a new project. This is what I did. I just need to click this. So you have this window, and you just come here to click your console application. Once you click that, you click your go, and the next thing, by default it will be on your C++, but you just need to change that to your C. Then you click next. Now you need to put a project title, whatever title you would want to give your project. In this case, let me just give it Femi. In this case, once you click in Femi, by default the code block itself will put in the project file name, which will be whatever project title you have given it, .cpb, which is your code blocks project. That is the file extension in this case. So this is the part, this is the folder where this project would be saved. You can equally change the path just by coming to click here. You can go to whatever path you want it to be, whatever folder on your system you want that project to be saved. But I have a default folder where I want all my C programs to be saved, so it's already there. I don't need to change it. In your own case, you might just have to change it to whatever suits you. Then you just click next and you finish. Now the compiler here is your GNU GCC compiler. So you can decide to have any, or there are so many compilers that you have here, but by default you just use your GNU GCC compiler. Then you click finish. So you have your project title here, which is your Femi in this case. So this is the environment for your code blocks. So here, these are your logs. Now down here you have your status. This is your status bar. This is your management window. This is your editor, and this is your toolbar. This is what is being shown. Is being shown here. your toolbars, your management window, your editor, your status bar, then your logs. So this is the same thing you have here. Your toolbar, your management window, your editor. These are your logs, and this is the status bar. So I want to have a new file, so I'm not saving that to the existing that I have. So this is your editor window now, where you have your cursor blinking. Whatever you want to do, you can put your codes here. Whatever you want to put in, you can put your codes there. So that is your editor window where you write in your codes. This is your management workspace. You can see I have my Femi, which is the file, the project title. So you have the source, you have the main, and in that main you have your untitled file. In this case, before you can run whatever program you have written here, you will have to save this first, and you have to give this a title. So that's why that is showing these asterisks here, because this is untitled just yet. So from your toolbar, you can open an existing project that you might have written before on your system. You can save. You can do your save as or save everything. Then this is your build. Before you can run any program in your code blocks, you need to first of all build and then use this play button to run. At the same time, you have this build and run button, so you can just click this. It will build and it will run your program. Now from these logs here, if you look at the logs here, you see that my build log is active. So what this means is that whatever is written, whatever is being logged here is related to my build log. I can try to change whatever log I want to see. So I can change them and see whatever is there. But by default, you have your build log active. So if there's any error with your code, once you build it, it will be registered here. And if there's no error, you will see that your code would run and there will be no error log against that very program here. And whatever output there is to your program, the output window will display such output. So we'll move forward now. Okay, we've discussed how to create a new project already discussed this. Now, what are the features of your C language? Number one is a high-level language. What that means is that any program, any program that is an high-level language, what it means is the codes or your programs are written in human understandable language. So when you're writing your program with English or any language that an human being can understand, it makes such a language for that program an high-level language, which means it will be user-friendly because human beings, or the user in this case, can comprehend such language. Another thing is that it is a structured language, so it improves clarity and quality and reduces the development time for designing such a programming software. Then it has a rich library. Now, there are already predefined libraries in your C program, and you can equally create your own library and include them by yourself. So libraries such as the arithmetic library, the logic operator library are already predefined in your C program, and also you can develop your own library and put it in by yourself. Then another thing that about your C language is that it is highly extensible. So extensible means that a user can define new features. So that's what it means by it being extensible. Then the recursion. Recursion means that if you have a function that you have already defined, you don't need to write that function repeatedly in the course of your program. Whenever you need to use that function again, all you need to do is just to call that function. So that is what recursion is all about. Then you have pointers. Pointers is whereby you can actually interact with the physical memory of your computer system from your program. That is what pointers is, when you are actually interacting with the physical memory of your computer system. So that is pointer. Then fast execution. Your C program or your C language is faster in execution compared to the languages before the C language. Then memory management. You can actually interact directly with the memory of your computer system using your C language. So those are the 8 features of your C language. Then the next thing you want to look at is your C tokens. Now there are 6 C language C tokens. Number 1 is your keywords, special symbols, your constants, the strings, identifiers, then you have operators. So this figure is only showing your C tokens. So the keywords, special symbols, constants, strings, operators, then the identifiers. Now your keywords. Your keywords are variables that have specified meanings and are already predefined in the C library. So what that means is you cannot rename or reassign or reprogram a keyword in C language, because those keywords are already predefined and they have specified meaning in the C library, so you cannot rename or reprogram them. So here in this table you have 32 keywords in your C language. So your auto, your double, your int, this is for integer, your long, your register, your return, your short, signed, size of, static for your variables, your if for your loops, your for, your go to, your continue when you are doing your loops, your else, your break, case, character, constant, do. These are keywords in C language. So these keywords cannot be reprogrammed, they cannot be renamed, because they already have predefined meaning in the C library. So that's for your keywords. Now your constants. Constants are equally variables, but they are different from variables, because once you define a particular variable name as a constant, whatever value you are storing in that variable name cannot be changed in the course of your program. Once you define it as a constant, whatever value you are storing in that variable name cannot be changed. So this is just the syntax. Your constant, this is the constant. Now this is the keyword for defining such a variable name. You can see here you have the const. So once you put a const to a variable name, whatever value you're storing, you're telling your C language that, okay, your C program, that this value cannot be changed, because you are giving it the data type of a constant. So this is the syntax for your constant token. So you can either use this syntax or you can use this syntax. We'll still look at all of this in detail as we go along. Now, there are 5 type of constants with your constant token. Now, your integers can be a constant, your floating point constant, you have character constant, you have string constant, Then you have the octa and the hexadecimal constants. Then the next token we'll be looking at is your string. Now your strings are a collection of characters. So when you're writing text in your editor, those are string. So on every string you're writing, you have to put them in your apostrophe. So we'll still look at that. So but just for you to understand the concept of all of these C tokens. So your strings are a collection of characters defined in form of an array. So when you have text, maybe your A, B, C, D, E, F, G, H, together as an array like that, your C language takes that as strings. So, and the data type for that is your character, that is your char. Now you see that this character is equally a keyword in C language. So this is your character here is equally a keyword in your C language. So character, then the string name, whatever name you want to give to that string, and the length of the string. So this is a syntax for that. Then the next thing is your identifier or identifiers in this case. So for every value or variable you want to use in your editor window, you must specify the identifier that will hold such a value or variable function. So your identifier basically are names that you have declared in your program to store a value or a variable function. So in this is the syntax. Number one, the first thing you want to put in is the data type, and this data type will come from a keyword type. You can see int is integer. You will see here that your int is equally a keyword. So what you're saying is that this identifier x here that follows this int keyword, this identifier x, is only storing a value that has to be an integer. So the first thing here is your data type, the data that this identifier x is storing. In this case, identifier x is storing the value 10. So value 10 is stored in identifier x, and the data type is an integer. Why is it an integer? Because this value of 10 does not have any decimal place. If it's 10.1, 10.2 now, then this x cannot be an integer again. It has to be a float. So in that case, what you will type before the x will be a float. That will be your FLOAT. Will be a float in this case. But because this is just 10, it's not 10.0, it's not 10.1, so it's an integer, then int x. Now this x is the identifier. This equal sign here does not mean that your x is equal to 10. What you're saying is that your x is storing the value of 10. So that's what it means, and the data type is int, which is an integer. So that is what an identifier is. And there are rules for you to create or declare an identifier in Python, in your C language. Number one, the first character for any identifier can only be an alphabet or underscore. So that means you cannot use a number as the first character in declaring an identifier. So the first character for any identifier must always be an alphabet or an underscore. And by the way, underscore is the only special character that you can have in an identifier. You cannot have any other special character in an identifier besides an underscore. And again, whatever succeeding character after the first character can be a digits or letters. What it means is you can have, like in this case now, int is the data type. The first character is an alphabet, which is your letter A in this case, and the succeeding characters in this case are digits, which is 3 and 0. So you can have such as an identifier. You see here the data type is an integer, int. The first character is underscore, and the succeeding characters are letters or alphabet in this case. So for every identifier, the first character must be either an alphabet or an underscore, and the succeeding characters after the first character could be digits or letters. And also you cannot have any other special characters to declare an identifier besides an underscore. So you cannot use an ampersand, you cannot use the percentage, you cannot use the hashtag in any identifier, because the percentage, the ampersand, the hashtag, they have their own specified operations in your C language. Like your ampersand now works with your print function, that's your printf command. Your percentage works with your printf as well, and your hashtag works with your preprocessor directives. So you cannot use any special character besides the underscore to declare an identifier. So now you cannot use a keyword also for an identifier. Now if you look at here, you have int, which is a keyword, and the next thing here is long. Long is a keyword, so you cannot use a keyword to declare an identifier. And also you see here that there's a space between A and B, so you cannot use space between identifiers. And also you cannot you cannot begin an identifier with digits. So the first character cannot be a digit for an identifier. So those are the 4 rules for identifiers. Now the next token we are looking at is your operators. Now there are quite a number of operators. You have the arithmetic operators. Those are your addition, subtraction, multiplication, and your modulus. Now let's just see one of the projects here. So let me just open this. So let me close this. So here now, this is a C program that I've written already. Now you see that if you look at this is my editor window. Now these 2 lines here and these are the preprocessor directive that I talked about. You can see that the hashtag is starting these 2 lines, and you have the stdio.h. Now the std means standard, and this io means input and output, and the .h here means the header file. So this means your standard input and output header file. That is what this line is saying. And here you have stdlib.h. So this is your standard library header file. So these are just 2 header files that are included in this editor window for this C program. Now you have your int main. So this is the main function in this case. So and is an integer. So and what you have from here to here, all you have between these 2 coil brackets here is your code. Actually, all of this. So this is the code here, and this last line return 0. This last statement here would always end your C program. So every C program would end with your return 0. Now, if you look at it, you see that at the end of every line, you have your semicolon. You can see here, semicolon. at the end of every line, semicolon, semicolon. Now, every line means a statement, and at the end of every statement, there has to be a semicolon. That's just like your full stop to every statement you write in your C language. So there has to be the semicolons. So you're saying that this statement has ended here. Now, the first thing I did here, I just want to show your arithmetic operation with this very code. So I'm declaring my identifier A, identifier B, and identifier C in this case as an integer. So that's why I have int, which is a keyword, and the next thing is the identifier, which is an alphabet. That's the first character in this case. So any character that follows this one can either be a digit or letter, but I'm not using that in this case. So I'm using int and A, and I'm storing the value of 12 in this identifier A. So I'm putting a comma because I want to put another identifier. So, and I'm putting B again as an identifier in this case, still an integer in this case. So I don't need to write it again here since they are on the same line. It's only separated by comma. So your C language still understands that this B here is having the data type of an integer. And I'm storing the value of 4 in this identifier B. If you look at this C now, I'm not storing any value in this C. I only put it there as an identifier, which is an integer. So that is the first line here. And the second line, I'm declaring my identifier G as a float. So, and I'm storing 2.3 in this identifier G. And because it has a decimal place of 1, that's 2.3, it has to be a float. It can't be an integer anymore. So it has to be a float. And also I'm declaring the identifier H as a float as well in this case, although I'm not storing any value in this identifier H at this time. Now this C here, I'm using the math operation summation here, which is addition. That's the operator I'm using in this case. So I'm saying my C is getting the value of A plus B. So my C is getting the value of A plus B, which is 12 plus 4, because I've already stored the value 12 and value 4 in A and B respectively in this case. And also my H is getting the value of A plus B minus G, which means 12 plus 4 minus 2.3. So that is what this line is doing. Now, for me to see the output of these two lines, I need to use my print function. Now, for me to use this print function, I need to have included this library of standard input and output. That is why I have this library here, this preprocessor directive. That's why I have it here as standard input and output, because I need to, print whatever the value of C and H would be. I need to print it. So that's why I'm using this library. Now, here, and I'm saying that, okay, my print function F, that's my print function, print F, because it's a function, whatever argument I'm passing would be in your parentheses, which is your normal bracket. And I want this string. This is a string now in this case, all of this. That is why they are in this apostrophe, these two apostrophe here. That's why you have them in this apostrophe. So it's going to print A plus B equals, now this percentage D is a data type. What it's saying is that this C that I want to print the value is an integer from here, because I've declared that my C identifier is an integer. So when I'm using the print function needs to know that what I'm printing, what data type is it. So that's what I've done here. This percentage D means that this C is an integer. So this percentage D is only telling my print function that this C here is an integer. So also, if you come here, you see that my print function for A plus B minus G equals percentage F. In this case, percentage F is telling my print function that my H, which is the identifier I want to print the value for, is a float. If you look at the second line here, I've already declared my H as a float. So coming here, the print function needs to know that this identifier H, what kind of data type does it hold? And I'm telling my print function that this is a float. So that is why you have percentage F and not percentage D in this case, because H is a float while your C is an integer. Now you see this forward or backward slash n. What that means, these are just special characters. So that is your new line character. So what it means is after this line has been printed, whatever is to come after this will be printed on another line. So that's what it means. If I should remove this from here and run this code, this next line will be printed directly in front of this in the output window. So we'll still look at all of that now. Now the next thing I'm printing here is that my C again is holding the value of A minus B, just to show you another arithmetic operator. And I'm printing the value. Now with the print function, A minus B equals my percentage D. And the identifier I'm printing the value for is C in this case. And my C from my declaration here is an integer. So that's why I'm telling my print function here that my C is an integer with this percentage D in this case. And also I'm doing my C equal is getting the value, not equal to, sorry, my C is getting the value of A multiplied by B in this case. And my C is equally an integer, so that's why I'm still using my percentage D to print the value of my C in this case. And also C getting the value of A divided by B, that it will be 12 divided by 4. And I'm printing that also using the same data type of percentage D, because my C is an integer in this case. And also I'm doing my C modulus, my C getting the value of A modulus B. Now in this case, when you have your A or whatever identifier or whatever variable, percentage another variable, in this case B. So this percentage in this case is a modulus. So what it means is that when A is divided by B, do we have a remainder or not? If there's a remainder, fine. If there's no remainder, we want to know. That is what this modulus would do. This operator, this percentage in this case is the modulus operator. Now, and the print function is remainder when A is divided by B is whatever remainder there is will be printed to the value of C. So, and also C is equally an integer, so that's why it's still percentage D. That is the data type that the print function is getting to determine what data type your variable C is. So we just run this. I will use the build and run in this case. So this is the output window. You will see here, let me just move this to the right here. So you see here that my A plus B equals 16, which is this. A plus B equals 16. A plus B minus G, which is this. The value of H in this case is 13.7. 000, that's 6 decimal place. Now you can equally reduce this decimal. You can specify the precision you want. We'll do that in seconds now. So this print function here is responsible for printing this line. This is the string a plus b equals c. This is just the data type of c, and this is just saying that the next thing should be printed on the new line. So this print function here is printing this on the output terminal. Now this next print function here is responsible for printing this on the output terminal, and this one, a minus b, this is printing this, and this print function here is printing this, and this print function here is printing this line, and this print function here finally is printing this, because there's no remainder in this case, because when you divide 12 by 4 you have 3, and there's no 3 point whatever it is, so there's no remainder. So your modulus operator only tells you if there's a remainder in any division that is done. So because there's no remainder in this case, that's why the value of c here is 0 in this case. So let's try to reduce this decimal place and see how you are going to do that. Let me close this. You have to close that, else you can't run the code again because your output window is still active, so you have to close it. So we want to reduce the precision on that float to 2 decimal place. So in between the percentage and the f, in this case, we just put 0.2. So that means you want 2 decimal place, or 0.3 or 0.1 or whatever it is that you want. So if you run this again now, you see that you can see that I have just 2 decimal place of 13.70. So also you can put maybe 0.4. So that will be 4 decimal place. Run that again now. You see that you have 1, 2, 3, 4. So that's how you determine the precision you want on your decimal place for a float in this case. Now let's also remove this new line and let's see what will happen if I remove the new line here. You will see that this next print will be printed directly in front of this. So you can see here now that the a plus b minus g is printed directly in front of a plus b equals 16. So it doesn't make the output very, very clean. So that is why you always need a new line, so that every output can be printed on separate line. So you can see, so that's what your new line command, that is what it does. So the next operator we'll be looking at is your increment and your decrement operators. Now these are used when you're writing loops. So we'll look in depth into increment and decrement operators when we are writing the for loop, the if, the while, the do while loop as we go along. But for your increment operator, when you want to increase the value of a particular variable by a specified number, that's when you use the increment operator, and your decrement operator when you want to decrease the value of a particular variable by a specific number. And the syntax is your I++ for your incremental or for your increments, and your I minus for the decrements. In this case, the I++ would be increasing the number by 1, unless you want to specify a particular number you want to be increasing it with, and your I minus will be decreasing the variable by 1, unless you want to specify whatever number you want that variable to be decreasing. Then you have the assignment operator. We have already talked about that, your equal to. So when you have your single equal to, you're saying that the identifier to the left side of your equal sign is storing the value of the variable to the right side of your equal sign. So that is what the equal to is saying. That is the assignment operator. And when you have the double equal to in this format, what you're saying is that whatever you have on the left is actually equal to what you have on the right. So when you want to specify that a particular identifier is equal to a particular variable, then you'll be using the double equal to sign to say it's actually equal to in this case. But when you are using a single equal sign, then you're saying You're only storing the value of that variable, that value in that very identifier. So this is just the syntax that we have seen already. Your data type int, the identifier b, the equal sign, and the value that is being stored in this identifier. Then your bitwise operators. So when you're working with binary, that's when you use your bitwise operators, your AND, your OR, your NOT, your NOX, your left shift and your right shift. Then you have the relational operators. So these are equally applicable when you're doing your loops. Your less than, your greater than, your equal to, your not equal to. So this is your less than, greater than, equal to, and this is not equal to. So what this means is that whatever is on the left is not equal to what you have on the right. So when you are doing your if statement, your for loop, your while, your do while loop, those are where you use your relational operators. So these are just operators in your arithmetic token, the meaning of such operators and the example of such operators. Then you have your logical operators under your arithmetic tokens. So you have the AND logic, which is your double ampersand, then your OR and your NOT. Those are the three logical operators that you have in your C language. Then data type and variables used in C programming language. These are basic data type that we have seen: your character, your boolean, your short integer, your unassigned short integer, your integer, unassigned integers, your long integers, your unassigned long integers, your long integers, your unassigned long integers, your float, your double, and your long double. These are your constant examples. So this is a new line. We discussed that already. So this is your float. Now you see this is the printf function that I was discussing the other time. And these are the characters you use to inform your printf function of what variable you want your printf function to print. So if you look at your float here, you see you have the %f, %e, %g, or %a. You can use any of these in your printf function to tell your printf function that the variable that is to be printed is a float. If you look at your integer, you see that it is your print I, print percentage, and your print O. And the print D equally works for your integer as well. So these are your character for your printf function. And for your double as well, your %f, %e, g, and %a. So let's just do something. Let's change this to %i. And let's see what would happen. You can see that we equally have our 16 for the integer type variable that is being printed with your printf function. But also you can use let me close the auto terminal. Also you can use the D like we have used before. And if it's the I that you want to stick with, it works the same way. So let me close the auto terminal and go back to so that is the basic data type that we have. Then we have your derived data type, your enumeration data type, and your void data type. Those are the 4 data types that you have in your C language that you have. Then variables. Now your variables are defined memory space that stores values of a definite data type. So there are different types of variables. You have your local variable. Now local variables are variables that are limited within your C language session. For instance, this variable that we have here, all these variables here, any variables you have, any variable you declare between these two curly brackets here, any variable you define here, they are local variable because they can only be used within this line of statements. You can't use any of these variables, all of this variables that we declared here, we can't use them outside this line because they are local. That's why they are called local variable. If they are defined, your function in this case becomes a global variable. So we can still access them within this line of code because I've defined them before the function main in this case. Let me just bring this down. So all of this now is a global variable, but this G and H here is a local variable. So when you define any variable before your main function that is holding all your command lines or your statements in between these two square brackets, so such variable becomes a global variable. But whatever variable you define within these two square brackets is your local variable. Then we have other ones too, like your static. Now the static variables are specified with the keyword static. So any variable you put the keyword static before you specify that variable name, so that variable becomes a static variable. What it means is that once you have declared that variable, the value of that variable cannot be changed, or that variable will retain that very declared value throughout your program. The value of such variable will not change. So if in some cases you want the value of a particular variable to remain the same in the course of the execution of your entire program, you use the keyword static to define such a variable. You give it a data type of static, so that makes it a static variable. Then also you have your external variable. So when you have a variable that is defined or declared with the keyword extern, so such a variable becomes an external variable, which means you can call such a variable in multiple C program files that you must have saved. So such variable can be called from multiple C programs that you have saved. So it's an external variable in that case. Then you have the automatic variable. Now by default, every variable in your C program are automatic variable, but also you can declare a variable as automatic with the keyword auto. So, but by default, every variable is automatic in your C language. Now, there are rules to declare a variable, just like you have for identifier. So, a variable can have an alphabet, digit, and underscore. So, a variable can be an alphabet, can be a digit, and can have the special character underscore. Now, your variable name must start with an alphabet and underscore only. So you cannot start a variable name with anything other than an alphabet or an underscore. And you can't put space or spacing between within your variable name. It will not be allowed. Then also the fourth rule is that the name, a variable name must not be any reserved word or keyword in your C language. So that means you cannot use a keyword or any reserved word to declare a variable. Just like you have with your identifier, they are pretty similar. So you have a preprocessor directive. Like we said already, any line you begin in your C language with this hashtag here, that line is a preprocessor directive, and such lines are used by the compiler. So your compiler needs this preprocessor directive to make sense of whatever program you are writing. So in this case, what the compiler will do first here is to activate the input and output channels, because I'm saying standard input and output header file, and I'm putting it as a preprocessor directive in this case with this hashtag. And also here I'm using the standard, that's your std lib, so your standard library header file. So what is telling the compiler in this case is that, okay, before you compile this program, before you translate it into the machine language, you must have activated the standard library, which is your memory allocation and freeing function files in this case. So that is what your preprocessor directives is all about. So before your compiler translates the program, it first of all uses the preprocessor directive you must have specified to activate what is required to compile whatever program that is being written into machine language. So this is just the process: your preprocessor directive, the compiler, the assembler, then the loader or linker in this case. So the types of preprocessor directives you have in C language, you have the hashtag include is a preprocessor directive. Then you have the hashtag define, hashtag undefined, hashtag if define, hashtag if and define, the hashtag else, hashtag error, and the hashtag pragma. So for the undefined and the defined, you use them to define a constant and undefine a constant. So these are the types of preprocessor directives that you have in C program. So that will be all for this session. Thank you.